In this lesson, we are now going to use some of our knowledge about radical and rational form to sometimes rationalize the denominator or just simplify different expressions. Number 9 doesn't really pertain to what we're doing today, but I want to remind ourselves what we do when we have a negative exponent. If I have x to the negative 2 power, in order for me to make that a positive, because remember we can't answer in negative exponents, I move that to the denominator. So if it's a negative exponent in the numerator, I would move it to the denominator, and that's my answer. That's how I would move that negative exponent. So it's just kind of a quick rule reminder. The reason we had that is because here I have 16 to the negative 1/4. I can't do anything with this but as far as putting it in radical form until I move that or make that exponent positive. So I'm actually going to rewrite this as 1 over 16 to the 1/4. And then I'm going to see if 16 is a perfect fourth. So if I wrote this in radical form, it'd be the 4th root of 16. Now I showed you how to do this on your calculator one day just kind of quick, but it's the same way you do the cubed roots. So you're going to turn your calculator on to find this, and you're going to press 4 because you're giving it the index. So you're going to say 4, and then you go over to math, and down to number 5. So I'm going 4, math, 5. And you'll see it's the button that has this x with a square root. The x is what you just put in, the 4. So you're going to hit that, and then you'll see the 4th root, and you'll see that space waiting. I'm going to punch in 16. Now I don't expect you to know the 4th root of 16 off the top of your head because we haven't worked with 4th roots very often, but hopefully when you see the answer it makes sense to you. When you see that it's 2, 2 times 2 times 2 times 2, would equal 16. So that makes sense that 2 to the 4th is 16. So because it's a perfect fourth, I'm going to write this as 1/2. The 4th root of 16 is 2. I simplified it. I don't have a radical in my denominator, which I did, right? So I had to get rid of it anyways, and it happened to be a perfect fourth, so I was good. Number 11 then, I don't have a negative exponent, so I can go straight to radical form. I would have the 5th root of 243 cubed. That's radical form. So before I cube 243, which I'm assuming is a pretty big number, I'm going to see if I can take the 5th root of 243. So I'd go 5, math 5, 243, enter. And I do see that the 3 to the 5th is 243. So the 5th root of 243 is 3. And then I still have this cubed here from right there because I didn't do anything with that. So when I take 3 cubed, I would get 27. So I'm reducing these as far as I can. Number 12, you'll see that I have a negative 32 to the 2/5. What I would recommend doing here, because this is not, there'd be a big difference in this problem if this was in parentheses. If this was in parentheses, the 2/5 would apply to that negative on the 32. Because it's not in parentheses, it does not apply to that negative. So I think it's smart to rewrite this as negative 1 times 32 to the 2/5. So you realize that negative has nothing to do with the 2/5. Then I'm going to break down, and I'm just going to bring this negative 1 along for the ride until I'm done. So I'd have negative 1 times the 5th root of 32 squared. I punch the 5th root of 32 in my calculator. I'll give you a second to try that. Hopefully you see that it's 2. So I'd have 2 squared, which is 4. Now I can put that negative back into my problem and see that I get negative 4. In case you're curious, putting the parentheses around that answer would have resulted in a positive answer. So that would have been, that's what makes it different. Number 13 then, my rule reminder you'll see here, x squared times x to the 5th. Remember, if we have the same base, this is considered my base, the x. If my bases are the same when I multiply, I can go ahead and just add the exponents. That's what I would want to do with this problem. My bases are the same. They're both 8s. So I'm going to leave this an 8, and I'm going to add those fractions. 3/2 plus 5/2 would be 8/2, which is really 4, right? So now all of a sudden this problem becomes 8 to the 4th, which is a little more manageable than what I started with. So when I take 8 to the 4th and I punch that in my calculator, I get 4,096. Number 14, In this problem, you'll see that I have this negative 2/3 that's going to apply to both of these. So what I would do is I would rewrite this problem as 8 to the negative 2/3 over 27 to the negative 2/3. Now, since I have negative exponents for both of these, they both need to flip spots, don't they? This needs to go up there to be positive, this needs to go down there. So when I rewrite it again, I would write 27 to the 2/3, because now it's positive, over 8 to the 2/3. Now I can move it to radical form and see if I can simplify it. This would be the cubed root of 27 squared over the cubed root of 8 squared. I can't leave that radical in my denominator, so I'm going to see if I can take the cubed root of 8. So if you don't know the cubed root of 8, you punch in your calculator. The cubed root of 8 is 2. So I now have 2 squared in the bottom. I'm also going to try the cubed root of 27, which hopefully we realize is 3. And then from here I have to square it, so I'd have 3 squared is 9, 2 squared is 4, 9/4 would be my answer. That one has quite a few steps to it, so you have to really know your exponent rules, and you need to know how you can transfer from rational to radical form, take the cubed root, all those. That's a lot of process in that one problem. 15 is a lot like 13, where I have the same base, so I'm going to add those exponents. 1/5 plus 7/5 is 8/5. I could move this to radical form, but if you remember from before, when this is an improper fraction, I know I need to reduce that somehow. So I'm going to rewrite this as 1 3/5. Then when I move it to radical form, I realize this 1 is an x to the first. And then I move this to radical form. It's the 5th root of x cubed. If I wouldn't have done that, and I would have gone straight to radical form, I would have had the 5th root of x to the 8th, and I would have had to do it anyways. So that would have brought me all the way back up here and back to that answer. So it saves me a little bit of time if I move that 8/5 from an improper fraction to a mixed number. Number 16, I have to add my fractions because I have two of the same base. I can't add 2/3 and 6/7 the way they are, though, because they don't have a common denominator. So I have to find one. Common denominator between these two numbers is 21. Take that times 7, so I've got 14. Take that times 3, so I've got 18. So I'd have 14 plus 18, which is 32. When I add those two fractions together, I get 32/21. Again, that's an improper fraction. So I'm going to make it to a mixed number, which would be x to the 1 and 11/21. And when I move that into radical form, I'd have x, because of this 1, and then the 21st root of x to the 11th. And there's my final answer. Here's another rule that we hopefully remember. When I have a power of a power, x to the negative 2/3 to the negative 1/6, my rule is that I multiply these. If I recognize that right away, I would see that when I multiply them, they become positive, because I'd be multiplying two negative numbers. So instead of trying to move things to the denominator and move them around, I'm going to multiply right from the start. When I multiply 2/3 times 1/6, I'd cross cancel there, and I'd get x to the 1/9. In order for me to answer this properly, because remember we can never leave an answer in rational form unless they ask for it, I'd move this to radical form. I know it doesn't reduce because this is not an improper fraction, so that's my final answer. 18, I have x to the negative 3/4. Now this I know that I have to move to the denominator to take care of it, so I'm going to rewrite this as 1 over x to the 3/4. If I wrote this in radical form, I would have to multiply by something to get rid of the radical. So we've done that before, so I'm going to show you now how to leave it in rational form to eliminate that radical. I need that denominator to become x to the first. So what plus 3/4 would make 1? That's what I'm looking for, because I don't want it to be a fraction, I want it to be x to the first. Hopefully we see that that'd be x to the 1/4. The reason for that is 3/4 plus 1/4, because they're the same base now, would be x to the first. And I no longer would have a radical in my denominator. If I do that to the bottom, I've got to do it to the top. So I'd have x to the 1/4 in my numerator. Now before I can finish, I need to put this in radical form. So I would write this as the 4th root of x to the first over x. Final answer. 19 there's a couple ways I could approach this problem. I would probably go ahead and distribute my 1/6 to both terms, which means I need to multiply those numbers. So I'd have x to the negative 1/18. I'm multiplying 1/3 times 1/6 over x to the negative 1. Again, that's negative 6 times 1/6. And then when I see that both these numbers still have negative exponents, I realize I've got to flip them around. So I would have x to the first over x to the 1/18. Now when I divide variables with exponents, I ask myself, bigger x, top or bottom? Well, 1 is bigger than 1/18. So I would take 1 minus 1/18 and get 17/18. I no longer have a rational exponent or a radical in my denominator, so I'm good to go. I just need to move this to radical form, which would be the 18th root of x to the 17th. Last one. This one again, I would apply my 3/4 to my 16 and my 12, so I take 16 times 3/4, which gives me 12. And I take 3/4 times 12, which gives me 9. Since I have different variables here, I have x's and y's, I can't do anything with these as far as dividing them. So even though this is our last problem, it is one of our easiest because we are done right here. So not all problems require quite a bit of work.